Fallout is everywhere. No, not the game or the boy, just the nuclear kind. Seven blessings, friends. Trace here for DNews. Nuclear fallout is an inevitable side effect of nuclear disaster. When a nuclear weapon is detonated or a nuclear power plant has its worst day ever, radioactive dust is thrown into the atmosphere by the explosive force. Those radioactive particles then fall back to Earth, causing nuclear fallout. Nuclear fallout is no different than the ash, dust, dirt, water, and other particulates that would be thrown by any explosion, except one key thing: it's all radioactive. Fallout forms within minutes of a nuclear explosion, and depending on how high the particles were propelled into the atmosphere, fallout can be carried by the wind and spread far and wide from the original nuclear disaster. How far? All the far there is. Before 1963, a handful of countries exploded more than 500 nuclear weapons in Earth's atmosphere, blanketing the entire planet in low levels of radioactive fallout. But don't worry, when it comes to radiation, it's about dosage, and usually that dosage is low but detectable. A 12-year study called the Baby Tooth Survey collected nearly 300,000 baby teeth from children in the St. Louis area and found a 100-fold increase of isotope strontium-90 that rose and fell in correlation with those atomic bomb tests. Again, super low dosage, but it was there. So how fallout can affect you depends on when you were exposed and also how. All radioactive heavy elements will decay, shooting off tiny high-energy particles over time. If those bits hit your DNA, they can damage it, causing cancers. This is why higher dosages are worse, because there are more of those particles decaying, causing more potential damage. So, the closer to the nuclear disaster you are, the more dangerous the fallout will be. For example, according to the National Cancer Institute and CDC, people living in the US from 1945 to 1963 likely ingested radioactive iodine-131 left from nuclear testing in the American West and over the Pacific. After the tests, the fallout particles blew over the US, were trapped by moisture, and rained down onto our fruits and vegetables. Those were then consumed by goats and cows, and the I-131 was passed into their milk. Eventually, people drank it, and the isotope lodged into human thyroids, decaying and occasionally causing thyroid cancer. Another example is the residents of Hiroshima and Nagasaki, who were closely studied after World War II. Researchers documented a late-life cancer rate that was much higher than the global population, things like bone and thyroid cancers, tumors, and leukemia. And this is still going on, as people in Nevada, New Mexico, and elsewhere eat local food grown in soil that has been contaminated by radiation. If, Darwin forbid, something nuclear did happen today, you could create a fallout shelter. Radioactive particles are easily blocked by things like dirt. According to FEMA, only a foot of concrete or a foot and a half of dirt would cut radiation dosages by 40 times. But you don't have to stay in that shelter as long as you think. The 7-10 rule says for every factor of 7 hours, the radioactivity decreases by 10. So 7 hours after the explosion, it's 10% as radioactive. 49 hours, that's 7 times 7, is only 1% of the original dosage, and at 7 times 7 times 7 hours, about 2 weeks, it's only 1/10 of 1% of the original, which is why FEMA says keep enough water and food for at least 2 weeks. The thing is, there's a weird benefit of global radiation exposure. The isotope plutonium-239 was released into the world at exactly 5:30 a.m. on July 16, 1945, meaning it's a good marker for scientists. They've been using PL-239 to determine the melting of ice caps and glaciers since its introduction, amongst other things. So sometimes destructive science, it can teach us a lot. Silver isotope lining? So if nuclear fallout causing cancer is the end of the line, where's the beginning? How do we make nuclear fuel? Don't worry, I made a super cool video about that right here. Nuclear fuel is commonly referred to in the news as highly enriched uranium, but getting it to that point requires a lot of effort. In 1941, Enrico Fermi created the very first controlled nuclear chain reaction using a small amount of uranium-235. And since then, we've gotten much better at taking uranium and creating usable fuel from it. Are you afraid of the fallout, even though it's around us all the time? You can let us know in the comments. Make sure you keep coming back here every day for more DNews, and thanks for tuning in.